Hello students, this is the second class of units and dimensions. In the first video what we have studied about what is units and what are physical quantities, what are the types of physical quantities. There were three types of physical quantities, right? Fundamental physical quantities, second one was derived physical quantities, and third one was supplementary physical quantities. And the next topic we have studied is dimensions, right? In the dimensions we have find out dimensions of many of the physical quantities, right? Yes. So now we are starting with next topic in the dimensions itself, that is principle of homogeneity. So our topic is now principle of homogeneity. Correct? What is the principle of homogeneity? Here the dimensions of each term of an equation must be same. Suppose there is an equation given to us, so we can write the dimensions of each term of an equation must be same, right? That is, suppose there is an equation like this, some term is there plus this minus this is equal to 0. Suppose this is the equation given to us. So the dimensions of this term, and this term should be same. Or we can write, we can add and subtract similar physical quantities. We can add and subtract similar physical quantities, right? Like we can add 4s plus 2s. This is feasible, right? If we have to write 4s plus 2 kg, we can add them? No. So this is the principle of homogeneity. Understand? Suppose we have a question, for example, find the dimensions of A and B in the equation V is equal to A plus BT. Okay, where V is velocity and T is time. So this is a kind of equation, right? So how we will solve this equation to find the dimensions? So we can write dimensions of A will be equal to dimensions of V okay. So dimensions of A will be, what is the dimension of E? Velocity. That is distance upon time. So from here the dimension of A will be m0 l1 t minus 1, right? So this is the dimension. From here we can find the dimension of b as well. What will be the dimension of b? It will be dimension of v divided by dimension of t. So v will be again lt minus 1 divided by t. So what will be the dimensions of b here? That is m0 l1, and t will be minus 1 and minus 1. T will be minus 2 here. So these are the dimensions of b. Correct? Yes or no? Yes. So this is the principle of homogeneity, right? Next topic we have here is dimensional analysis, because we have to find the relations between physical quantities using the dimensional analysis. We will be doing more questions. First, we should understand what is the dimensional analysis. So next we are doing dimensional analysis. For dimensional analysis, we have to derive the relations between the physical quantities. So deriving the relations between physical quantities PQ we can denote using the dimensional analysis. DA, right? For example, we can have a question. Force F on a particle depends upon first mass m of the particle, and second one is acceleration of the particle. Okay, so we have to find the expression for force. Force F. So what will be the solution? How we can find this? So deriving the relations between physical quantities, first we have to write which quantity is depending. So F is depending here firstly on m, that is mass. We can write m raised to power x. Then force is also depending upon acceleration. We can raise it to power y. If we are combining these two, F proportionality sign will remove, a constant will come, k m raised to power x, a raised to power y. Correct? K here is dimensionless. Okay, proportionality constant, because proportional sign we have removed, so it is dimensionless proportionality constant. Okay, now we can find the dimensions. So what we can write is dimensions of f is equal to dimensions of m raised to power x, dimensions of a raised to power y. What is the dimensions of f? You know, force is mass into acceleration. So that will be ml t minus 2. So we are writing the dimensions ml t minus 2, right? It will be equal to m raised to power x. And what are the dimensions of acceleration? L t minus 2 power y, right? So we can write ml t minus 2 is equal to m raised to power x, L raised to power y, t raised to power minus 2y. Okay. Now comparing on both sides, what is there here? m1 is equal to m raised to power x. So x will be equal to 1. L1 is equal to L raised to power y. So y will be equal to 1. Okay. And if we can compare with t also, minus 2 is equal to t minus 2y. So it will be minus 2 is equal to minus 2y. Y will be equal to 1 from here as well. So we have x is equal to 1 and y is equal to 1. Substituting in this formula for f, what we have calculated, f is equal to k m raised to power 1 a raised to power 1. This proportionality constant is 1, so f will be equal to ma. This is the formula of the force. So with this type we use dimensional analysis. Okay, yes, let us move to the questions. Now we are solving some questions which are asked in the previous exams. Firstly, we are taking the questions of this year 2023 JEE Mains. Okay, so first question is this: the speed of a wave produced in a water is given by. So what will be the solution we have to find? V is given to us as lambda raised to power a, g raised to power b, and rho raised to power c, where lambda, g and rho are wavelength of the wave and acceleration due to gravity and density of the water respectively. So we have to find the values of a, b and c respectively. Okay, so this is the dimensional analysis question. So firstly we will write the dimensions of all. What is the dimensions of v, speed of the wave? It is m0 l1 t minus 1, right? What will be the dimensions of wavelength? What is the dimensions of wavelength? L in meters. What is the dimensions of g, acceleration due to gravity? So it is same as acceleration. It will be L1 t minus 2. And what are the dimensions of density? Density is mass upon volume. So dimensions of mass and volume, it will be mass and volume will be L cube, right? So what are the dimensions of density? m1 L minus 3. Okay. Now substituting in the above equation using dimension formula. Okay. We can substitute the dimensions of all velocity m0 L1 t minus 1 is equal to L1 power a. What is the dimension of G? L1 t minus 2 b. And what is the dimension of density? m1 L minus 3 raised to power c. It is same m0 L1 t minus 1. We can combine all these. M raised to power c L raised to power a plus b minus 3c and t raised to power minus 2b. Correct? Now we can compare on the both sides. M raised to power 0 is equal to m raised to power c. So it will be c is equal to 0. Okay. And this one is a plus b minus 3c is equal to 1. And this is minus 2b is equal to minus 1. So it is cancelled. B will be 1 by 2. And c is 0. So we can substitute in this equation b and c. We will get a. A plus b is 1 by 2 minus 3 into 0 is equal to 1. A plus 1 by 2 is equal to 1. A will be 1 minus 1 by 2. So A will be 1 by 2. So we have find out A, B and C. So A is 1 by 2, B is 1 by 2 and C is 0. So this is the answer. So which option is matching with A, B and C? 1 by 2, 1 by 2 and 0. C. The D option is matching, right? So this is the answer of this question. So option D is the answer. Is there any doubt in this question? No? Okay. Let us move to the next question. Next question is, in the equation x plus a divided by y square, y minus b is equal to rt. So the equation is given to us. What equation is given? X plus a divided by y square, y minus b is equal to rt, right? Where x is pressure and y is volume, r is universal gas constant, and T is temperature, right? These quantities are given to us, the physical quantity equivalent to the ratio A divided by B. So A divided by B we have to find. So from this equation what we can say is x and a by y square has same dimensions and y and b will have same dimensions. Okay, so x is representing pressure. So what is the dimension of pressure? It is force upon area. So it will be force is ml t minus 2 divided by area is L square. So what is the dimension formula of pressure? M L minus 1 T minus 2. This is the formula of pressure. Okay. For volume, we have L cube, right? So firstly, we will find X and A by Y square has same dimensions. Okay, we have studied the principle of homogeneity. These two equations have same dimensions. So we can find A by Y square is equal to M L minus 1 T minus 2, right? Then the dimensions of A will be M L minus 1 T minus 2 into Y square. That will be M L minus 1 T minus 2. What is the dimension of Y? L cube. L cube into 2. That is L6. So the final A dimensions is M L raised to power 5 T raised to power minus 2. Right? Now V and Y has same dimensions. Okay. So what will be the dimensions of B? It will be equal to dimension of Y. So what is the dimension of Y? Y is volume. So it will be L cube. Right? Let's find the dimension ratio A divided by B. A divided by B we have to find. So divide A and B dimensions. M L5 T minus 2 divided by B is L cube. So it will be M L2 T minus 2. So what are the dimensions ML2 T minus 2? This is the dimensions of energy as we know, right? ML2 T minus 2. So the answer is energy. So option B is the answer. Okay. Yes, we have calculated with this only. Okay. Let us move to the next question. We have to match list 1 with the list 2. Correct? Spring constant, angular speed, angular momentum, moment of inertia. 4 physical quantities are given. We have to find the dimensions of each quantity and match them. Right? So how we will find? First we can find for spring constant. Correct? The spring constant is related to Hooke's law. Yes. Which states that force exerted by a spring is proportional to its displacement. If we remove the proportionality sign, it is F is equal to Kx, right? So we can find dimensions of K from here, which will be dimensions of F divided by dimensions of X. F is force. What is the dimension? ML T minus 2. And this X is the displacement. It is in L meters. So what are the dimensions of k here? M t minus 2, right? These are the dimensions of spring constant. So a spring constant is matching with which one? Mt minus 2. Mt minus 2 is in second option. So this is second. Now we can find for angular speed. Okay, angular speed is omega. What is the angular speed? It is the rate of change of angular displacement with respect to time. This is rate of change of angular displacement, that is plane angle with respect to time. So this is dimensionless as we have studied. So what will be the dimensions of omega only? That is 1 by t, time. So it will be t minus 1. This will be the dimension of angular speed. So t minus 1 is in first option. So B is matching with first. Correct? Now third quantity, it is angular momentum. How we denote angular momentum? By L. Right? So angular momentum L is the product of moment of inertia and the angular velocity I into omega. Right? So what is the dimension formula for L? I is ml2, and what is omega? We have studied t minus 1. So what will be the dimensions of L here? It will be ml2 t minus 1. So ml2 t minus 1 is in fourth option, C. So this will be the fourth. Now D is moment of inertia. This is I. So we have to calculate moment of inertia. It is an object resistance to rotational motion. So it depends on mass of the objects and its distribution around the axis of rotation. Okay. So what is the dimensional formula of I? I have told you. ML2. Correct. So ML2 is in the third option, C. So we have written A with second, B is matching with first, C is matching with fourth, and D is matching with third. So which option is correct for this question? Second, first, fourth, and third. C option. So the C option is correct. Okay. These are very simple questions. You can solve easily if you know the dimensions, that how to solve the dimensions. Right? Let us move to the next question. Have you understood the previous question? Is there any doubt? Okay. Given below are two statements. So here two statements are given to us. This is the statement 1 and this is the statement 2. Statement 1 is astronomical unit AU, parsec PC, and light year LY are the units for measuring astronomical distances. Okay, and in the second, AU is less than parsec, parsec is less than light year. In the light of above statements, choose the most appropriate answer from the options given below. Okay, so here statement 1 is given that astronomical unit, parsec and light year are the units for measuring astronomical distances. Firstly, we can write what are these units. Suppose 1 AU is given, 1 astronomical unit. So it is the average distance from the earth to the sun, which is approximately 93 million miles. And or we can write it in kilometers. It will be 150 million kilometers. Correct. So this is the 1 AU, 1 astronomical unit. If we can write 1 light year, what is this? This is the distance that light travels in 1 year in vacuum. Okay, which is approximately 9.461 trillion kilometers. Okay, next is 1 parsec. PC. This is approximately equal to 3.26 light years, or we can write it as 30.9 trillion kilometers. Okay, so these are the three quantities in the question given to us. Okay, so first statement is correct as they are the units for measuring astronomical distances, because these three units are for distances only. Okay, so statement 1 is correct. Okay, now what about statement 2? Okay, so statement 2 is AU is less than parsec is less than light year. Is it correct? No. See, AU is less than light year is less than parsec is not correct. Okay, yes. So this is false. You can see the values. AU is 150 million kilometers, light year is 9.461 trillion kilometers, and parsec is 30.9 trillion kilometers. So that's why it is not correct. So statement 1 is correct, but statement 2 is not correct. So this is option number D. So D will be the answer of this question. Right? Yes. Let us move to the next question. Match list 1 with list 2. In the list 1, some physical quantities are given, and in the list 2, their units are given. Okay, we have to match them. For A, what is given? Torque. What is the formula of torque? Force into displacement. Force is mass into acceleration into displacement, right? So mass is in kg and acceleration is in meter per second square and displacement is in meters. So what will be the total units of torque? Kg meter square per second square. So in which option it is given? Kg meter square per second square in fourth option. So A is matching with fourth. Okay. So like this we can find. Yes. Next is energy density. So we can find the dimensions of energy density as well. What is the formula of energy density? Yes. Energy density is energy upon volume. What is the unit of energy? Yes. In the dimensions we can see what is the unit of energy density, because energy upon volume, and energy is m a into d divided by volume. Volume is meter cube. Okay. So what will be the value of energy density? It will be kg into, it is meter per second square into meter divided by meter cube. So it will be kg meter minus 1 per second square. So which is the option? First is matching with the first option. Similarly, we can find others also. Pressure gradient. What is the formula of pressure gradient? Anything, if we have to find for gradient, that means we have to divide that quantity by length. Yes. Suppose if we have to find the pressure gradient, we have to divide that quantity by length. Is it correct? Yes or no? Yes. Okay. So how we can find pressure gradient? It will be pressure divided by length. That is pressure divided by distance. So now what we can write by pressure? That is pressure on. So pressure is the formula force upon area into length. So this is the formula. What is the unit of force? Mass into acceleration. Again, A into L. So mass will be kg meter per second square. Area is meter square and length is in meters. This will be cancelled. It will be kg meter minus square second minus square. So this is matching with the option third. So it is third. Now fourth quantity is impulse. Impulse is equal to force into time. So force is kg meter per second square into time is seconds. So impulse will be kg meter per second. So this is matching with the second option. Correct? So what will be the answer? A 4, B first, C third, and D second. So this is in the A option. So A option is the right answer for this question. Right? Let us move to the next question. This is the question of JEE Mains 2022. Till now we have solved the questions of this year. Okay. So this is the next question here. Given below are the two statements. One is labeled as assertion and other is labeled as reason. So two are given, assertion and reason. Time period of oscillation of a liquid drop depends on the surface tension. If density of the liquid is rho and radius of the drop is r, then T is equal to K under root rho r cube divided by s raised to power 3 by 2, where K is dimensionless. Okay, it is saying that it is dimensionally correct. So what will be the dimensions of all these quantities? First, we can find the dimension, write the dimension of surface tension. Surface tension is mt minus 2, right? Next is rho density. Density is ml minus 3. And next is radius of the drop. Radius of the drop is in meters, so it will be L. Right? And in the reason it is given using dimensional analysis, we get right hand side having different dimensions than that of time period. So firstly we have to calculate the dimensions of right hand side. Okay, so right hand side the quantities are given in under root, so we can write rho ml minus 3 power half r cube L cube power half divided by s raised to power 3 by 2 mt minus 2, 3 by 2 into 1 by 2 of under root, this will be 3 by 4. So we can calculate it, m raised to power half L raised to power minus 3 by 2 L raised to power 3 by 2 in the denominator, m raised to power 3 by 4 and t raised to power minus 3 by 2. Correct? So we can calculate it. M total is 1 by 2 minus 3 by 4. L is minus 3 by 2 plus 3 by 2 and T will be, what is the value of T here total? 2 into 3, oh sorry, it is 2 into 3 by 4. That means it is 6 by 4. By mistake I have written minus 6 by 4. Okay, so T is minus 6 by 4. So we have calculated it is m raised to power minus 1 by 4, L raised to power 0 and T raised to power 3 by 2. So this is the answer of right hand side. Okay. Okay, and we have dimensions of left hand side as time period. So what is the dimensions of left hand side? Only time period is there, so only t is there. So they both are not equal, because dimensions of left hand side is this and right hand side is this. So what we can say from here is that A is false but R is true, because using dimensional analysis we get RHS having different dimensions than that of time period. So it is correct but it is wrong. So D is the correct answer for this question, because in the D it is giving the answer. Correct? Okay. One more question, last question we are going to solve now. Consider the efficiency of Carnot engine given by eta alpha beta divided by sine theta log base e beta x divided by kt, where alpha and beta are constants, T is the temperature, K is the Boltzmann constant, theta is the angular displacement, and x has the dimensions of length. Then choose the incorrect option. So we have to find incorrect options here. So since dimensions of trigonometric functions and log functions are dimensionless quantities, right? So we can write here the dimensions of eta will be dimensionless according to this m0, l0, t0. Right now we can write the temperature dimensions. It will be m0, l0, t0. Only k will be there because of temperature. If we have to write the dimensions of Boltzmann constant k, it will be m l2 t minus 2 k minus 1, and the dimensions of x length is l, right? So we can write it as m0 l1 t0. Okay, so we can calculate one by one. That A option is dimensions of beta is same as that of force. So dimensions of beta we can find, it will be kt by x. Okay, Boltzmann constant to t. So we can calculate k into t, m l2 t minus 2, right? K minus 1 plus 1 will be 0 and l. So it will be m l t minus 2. So this is the force dimension, right? That means this is correct. We can write with a dimensions of alpha minus 1 into x is same as that of energy. Okay, so dimensions of alpha beta from here is 0. They are constant m0 l0 t0, and alpha minus 1 will be equal to beta, which will be equal to kt by x, because of principle of homogeneity, right? So dimension of alpha minus 1 into x will be equal to k into t. So k into t is ml2 t minus 2. Correct? So this is the dimensions of energy. Now we can check C. Dimensions of eta minus 1 sine theta is same as that of alpha beta. So alpha beta is this dimensions. So we can check for eta sine theta formula first. Eta sine theta from the equations, because eta sine theta will go there. It will be equal to alpha into beta. Okay, so what will be the dimensions of eta sine theta? Will be dimensions of alpha into beta. So eta will be m0, l0, t0, right? Because it is dimensionless quantity. Correct? Now for the D option, last option, dimensions of alpha is same as that of beta. No, dimensions of alpha is not equal to dimensions of beta. Okay, so what will be the answer in this question? This one, that is not equal, because we have asked incorrect option. So A is correct, B is correct, and C is correct. So D is not correct, because this is the option which is not correct here. Okay, so we have completed all the questions. JEE Mains 2022 and JEE Mains 2023. With this, our topic is complete for the dimensional analysis. Okay, we have studied units and measurements as well, and dimensions as well. Dimensions, principle of homogeneity as well, right? So in the next class, we will study significant figures. Okay, yes, that will be the next topic in the next class. We will study significant figures. Okay, okay, thank you for